Verify that the medians of the triangle ABC are concurrent if the coordinates of the points A, B, and C are given to us. Okay, let us begin. First, let's try to understand the problem graphically. So here we have the triangle ABC. The coordinates of the vertices A, B, and C are given to us. D, E, F, these are the midpoints of the side BC, CN, and AB respectively. So we join point A and point A, so that's going to give us the median AD. Similarly, we have the median BE and BF. We need to show that these three medians are concurrent, meaning they meet at the same point. Let's call it the point O. Okay, now in order to verify that the medians are concurrent, so what we'll do, we'll try to find out the equation of each of the three medians. So here, since D is the midpoint of BC, we can immediately obtain the coordinates of point D. Similarly, we can obtain the coordinates of point E and F, and then we can use the two-point form to obtain the equation of the median AD. Okay, let's first begin by computing the coordinates of point D. So what we'll do, we're going to take the sum of the x coordinates of point B and point C. So negative 2 added to 0, that's going to give us negative 2, divided by 2 gives us negative 1. Then we take the sum of the y coordinates. So we have 1 added to 6, that's 7, divided by 2 gives us 7 over 2. So now we have the coordinates of point D. Similarly, so let's note it down, that is negative 1 comma 7 over 2. Similarly, we can find out the coordinates of point E and F. So let's note them down as well. The coordinates of E, that's 1 over 2 comma 4. All we have to do is take the sum of the x coordinates of the endpoints and divide it by 2. Similarly, for the y coordinates, take the sum of the y coordinates of the endpoints and divide it by 2. And the coordinates of point F, that's going to be negative 1/2 comma 3 over 2. So now we have obtained the coordinates of DEF. So we are ready to find out the equation of the median. So let's begin by first computing the median AD. Equation of the median AD. We're going to use the two-point form of a line. So here the two-point form of a line, which is given by y minus y1 equals to y2 minus y1 divided by x2 minus x1 whole multiplied to x minus x1. So we can consider x1 comma y1 to be the point A and x2 comma y2 to be the point D, such that we now get y minus y1. y1 is going to be the y coordinate of point A, that's 2, equals to, now we need y2 minus y1. So we'll do 7 over 2 minus 2 divided by negative 1 minus 1. This is going to get multiplied to x minus the x coordinate of point A. So that's 1. Okay, so let's simplify that. So we have y minus 2 equals to, so 7 over 2 minus 2, that's going to be 3 over 2. So we have 3 over 2, and in the denominator, negative 1 minus 1, that's negative 2, multiplied to x minus 1. Okay, further simplification gives us y minus 2 equals to negative 3 over 4, multiplied to x minus 1. Let's cross multiply, we get 4y minus 8 equals to negative 3x plus 3. Okay, rearranging the terms, we have 3x added to 4y equals to 11. So we have obtained the equation of AD. So let's label this as number 1 and we're going to set that aside. Next, we will try to find out the equation of the remaining two altitudes. So let's find out the equation of the altitude BE. So we need y minus y1. So we're going to consider y1 to be the y coordinate of point B. So let's that be 1. So we have y minus 1 equals to, now we need is the difference of the y coordinate, 4 minus 1 in the numerator divided by the difference of the x coordinates. We have half minus negative 2. So we're going to get half added to 2. This is going to get multiplied to x minus x1. So here negative x1 is negative 2. So we're going to get positive 2 here. So we have y minus 1, that's going to be equals to 3 divided by half added to 2. So that's going to be 5 over 2 multiplied to x plus 2. So we have y minus 1 equals to 6 over 5 multiplied to x plus 2. Let's cross multiply to get 5y minus 5 equals to 6x plus 12. Or we get 6x minus 5y plus 17 equals to 0. That's going to be the equation of PE. And then equation of Finally, CF, I'm leaving that as an exercise for you to try out. That comes out to be, we're going to get 9x minus y plus 6 equals to 0. That is going to be the equation of CF. So now we have obtained the equation of all the three altitudes. So let's take two altitudes at a time. So if we take any two equation at a time, so let's take AD and BE. So when we solve these two equations, now I'm leaving the solving part as an exercise for you to try out. So AD and B, when we solve, we get x equals to negative 1/3 and y comes out to be equals to 3. Next we can do is take AD and solve and take the altitude CF. Again, solve these two equations. That should give us x equals to negative 1/3 and y equals to 3. And then we are going to take the altitude BE and CF, and also here we will see that x comes out to be negative 1/3 and y is going to be equals to 3. So which means that all of the three medians are going to intersect at a single point having the coordinates negative 1/3, comma 3. So that is going to be the coordinates of the point O. So here we can say that hence the three medians of the triangle AD, BE and CF are going to be concurrent. Hence proved.